Okay. All right. So today we're going to learn how to solve problems involving probability of combined events. So this is the last subtopic for chapter 9, sorry, probability of combined events. So it's including independent events and also mutually exclusive events, all right? So a fair dice, so let's see example 8. A fair dice is rolled twice consecutively. If this experiment is carried out 540 times, how many times at least one perfect square be obtained? Okay, a fair dice. So what is perfect square here? All right, so it's a dice. All right, so the sample space. Okay, the sample space will be, oops. Okay, the sample space will be 1, 2, 3, 4, 5, and 6. So let's say A is a perfect square. Okay, perfect square. Hence, the elements of set A will be 1 and 4. Okay, so how many times will be at least one perfect square be obtained? So you can see here, okay, if we draw out the tree diagrams. Okay, a fair dice roll twice, so that means you have A and non-A. So A, so the probability of getting an A, so is will be very clear, 2 over, okay, the number of samples is 6, okay, the number of A is 2, okay, so the probability will be 2 over 4, there will be, sorry, 2 over 6, there will be 1 over 3, so 1 over 6 is 1 over 3. Therefore, you can see here the tree diagram. Okay, we draw out the tree diagram. So A and non-A. A will be 1 over 3 and non-A will be 2 over 3. Then the second row, okay, still the same, A and non-A. Okay, and then if you have non-A for the first time, then the second time you still have A and non-A, right? So the probability is still the same, 1 over 3, 2 over 3, 1 over 3, and 2 over 3. So the outcome will be AA. AA is both perfect square, A and non-A. So first time you roll, you get a perfect square. The second time you don't get a perfect square. Yeah? Then you have A prime, A, okay, and then A prime, A prime. A prime, A prime means there is no perfect square. So hence we have, this is our outcome that we want. So what we do is, all right, so you can find out the probability will be 1 over 3 times 1 over 3 here. This is 1 over 3 times the probability, like we put P here, probability. Then 2 over 3. Then 2 over 3 times 1 over 3. And then the last one will be 2 over 3 times 2 over 3. So the probability of getting at least one perfect square, okay, one perfect square. So you can either add this all together, or you just 1 minus 2 over 3 times 2 over 3. So you will get here is 4 over 9. 4 over 9, so you get 5 over 9. So this is your answer for number 1. But not yet finished, right? Because we want to find out if we throw the experiment carried out 540 times. So how many times you will get at least one perfect square. Therefore here, okay, I extend here. So we use this formula, n times p. So we call it expectant of x. Okay, so this one n is 540 times. You multiply 5 over 9. So it's 540 divided by 9 is 60. 60 times 5 is 300. So the answer is 300 times. Okay. Right. So you can check. Let's see the answer that I already done. Okay. This one. All right. So I think this one is wrong, huh? Okay. So at least one perfect square. Right. So we go to number 2. A box of contents of 7 red marbles, 5 yellow marbles, and 3 blue marbles. 2 marbles are chosen randomly, one by one from the box. If the first marble is blue, the blue marble is returned to the box before the second marble is chosen. Right? If the first marble is not blue, then the marble is not returned to the box and the second marble is chosen. So calculate the probability of getting 2 marbles of different colors. Okay, so here we need to draw out the tree diagram, right? So tree diagram. Okay, so tree diagram, it will be red, yellow, and blue. The second time, you also get red, yellow, and blue. This one is the same. Red, yellow, and blue. So here is also red, yellow, and blue. So the probability of getting a red marbles is 7, right? 7, 5, 3. So the number of sample here for the first time is 7 plus 5 plus 3. Therefore, you get 15, right? So therefore, we have a marble, red marble for the first time is 7 over 15, then 5 over 15, and also 3 over 15 for the first time. Okay, then second marble, when second time we choose, we pick up from the box, then it will be different. If blue, then it means you put in back, right? So that means here, the probability is the same, right? Still 7 over 15. Here is 5 over 15. Here is 3 over 15. It's a part only. Okay, so if it is not blue, okay, that means it's red and yellow. So therefore, if you take one red out, then it will be less one red. So meaning that this one will be 14 and this one 6. Okay, and then the probability here will be, the yellow probability is still the same, 5, but over 14. And the blue is same, 3 over 14. How about yellow? If yellow you take out, then you won't return back. So therefore, the red marbles is 7 over 14. The yellow marble will be 4 over 14. And then the blue marble will be 3 over 14, right? So this is called conditional probability. So you can see here. So now we want to find out the probability of getting 2 different colors marble. So what we do is we use this formula, 1 minus the probability of getting 2 red and minus the probability of getting 2 yellow and minus the probability of getting 2 blue. So what we are looking at is actually red, yellow, and green, yellow. Hold on, I think I used the wrong highlight color. So it's red, yellow, and blue. Okay, so 1 minus red will be 7/15 times 6/14. Okay, because first time you take red out, you don't return it. So that means the second time you take out, the total number of marbles will be 14, and the red marbles, of course, is less 1. Right? Then you minus the yellow. Yellow is the same also. When you take out 1 yellow, then you don't return back. So that means you get 5/15 times 4/14. Then lastly, blue color. If you take out blue, you still return back. So therefore, is also still remain 3/15. So you can use your calculator to get the answer, right? So you get 1 times 1 minus 7/15 times 6/14 minus 5/15 times 4/14, then minus 3/15 square. Okay, so you get this value, that is 349/525. So this is your answer. Okay, so let's check my previous answer. Hopefully is okay. I don't have the answer here. Okay, but this one is wrong now. So 1/, so it's 2/3 lah. So 2/3, 2/3. Okay, so it'll be 5/9, 5/9. So this one will be 5/9 times 540. So it's 300. Huh? Okay, so then we go to question number 3. Okay, number 3, perfect. Okay, so number 3, 2 dice A and B with 4 faces, 1, 2, 3, 4, and 4, right, are thrown. Determine the outcome of scoring the number 4 on dice A and the odd numbers on dice B. Hence, find the probability of getting a number 4 on dice A and odd numbers on dice B. Okay, so what the outcome? So A here, what is the outcome? So the outcome will be 4, 1, and 4, 3. Okay, so let's say this is event A. So therefore, the number of A is 2. So what is the number of element of the sample? That means 4, right? So it's 4/4. So it's 16. Okay, so the answer would be probability of A is 2/16. So 1/8. Okay. All right. So determine an outcome of scoring the odd numbers or even numbers on both dice, and hence its probability. Okay. So what's the outcome? Both are odd. So both are odd. This means A and B, right? So here is, let's say this is A and B. So if we list down, okay, or you use a table or geometric coordinate, okay, let's say, so it's 1, 2, 3, and 4. This is dice A, dice B. So 1, 2, 3, and 4. Okay, so both are odd numbers. You can see 1, 1, 1, 3, 2, 2, 4, 4, 3, 1, and 3, 3, and 4, 2, and 4, 4. So the outcome will be, okay, let's say this is B. So the outcome we write down 1, 1, 1, 3, 2, 2, 2, 4, and 3, 1, 3, 3, 4, 2, and 4, 4. Okay, so the number of B is 1, 2, 3, 4, 5, 6, 7, 8. So number of samples still the same, 16. Okay, so now samples is 4 by 4. 16. So therefore, our probability of getting a B, event B, is 8 over 16. There is 1 over 2. Okay. All right. So this is number 3. So let's see. Yeah. So all right, I think this one is something wrong here. Okay. So I think odd or scoring or odd numbers or even numbers on both dice. Okay, so this is correct. Huh? Okay, let's do number 4. A bag contains of white ball and 2 blue balls, and Roslan chooses to choose 2 balls at random, one by one from the bag. Okay, this is the outcome of the event when he gets the white ball and a blue ball, and hence that the probability of the event. So here we have used 3 diagram. Huh? So because only 2 events, so therefore is white ball, a white ball, and 2 blue ball. Okay, 2 blue ball. So that means you have B1, B2. So if you take 2 balls, that means after you take one Y ball, W ball here, so you only have blue 1 and blue 2. If you take out B1, then you have white and blue 2. And then you take out blue, then you have white and blue 1. So the outcome will be W, B1, W, B2, B1W, B1, B2, B2W, and B2, B1. Remember, this one is choose one by one. So you have to list down blue 1, blue 2. So if you said take out the balls simultaneously, then we don't put B1, B2. Okay. So list the outcome, the events that white ball and a blue ball. All right. So white ball and blue ball, there will be this one, these 2, 3, and sorry, it's not included. This one, it should be the last one, B2 W. Okay, and set the right. So let's say A is a white and a blue. Okay, so therefore we have white B1, white B2, so comma, comma, and then B1 white, B2 white. Okay, so the total of A is 4. Okay, then the total of sample, so you can see here 1, 2, 3, 4, 5, 6 or 6. So probability of A is 4 over 6. Therefore is 2 over 3. Okay, so this is A. How about B? Okay, this is the outcome that the event when it gets a white ball or a blue ball, and hence that the probability of the event. So white or blue. So white or blue, that means either white ball or blue ball. That's been in the outcome, you get a white or you get a blue is your answer. Therefore, you can see here white, blue, blue, white, a ball, a blue ball, white ball or a blue ball. Therefore, is This is the outcome that events. He gets a white ball or a blue ball. That means a white ball or blue ball. That means is either white, blue one, white, blue two, blue one, white, or blue two, white. It doesn't mention about blue, okay? But here, because it's a blue ball, he gets a white ball. Of course, it's white B1, white B2, B white, B1 white, B2 white, okay? For the case of blue ball, a blue ball, okay? This is the outcome that the event, he gets a white ball or a blue ball. White ball or a blue ball. So that it means that it doesn't cover, it doesn't include both are blue, okay? So therefore is actually the same as white and blue, okay? So it's actually same as equals to B lah. The event will be that is a white or a blue. So this is the outcome. So the outcome is the same. White B1, white B2, B1 white, B2 white. Okay, because it's a white ball and a blue ball. If the question said he gets a white ball or blue balls, then it's included in B1, B2. Right, so here the probability is the same as probability of A, that is 2/3. Okay, so that is the example 8. So let's go to example 9. Okay, so before that, let's see the what I have done before. Okay, so you see here, here is my understanding is white, blue, B1, B2. But here is only, now when I read through, this is not included. So not included, that means is 2/3 here, okay? So this is another way to find the probability. If the question didn't say list the outcome, then you can use this method, right? So P white blue or P blue white. So it's 1/3 times 2/2 by calculation. That means you use the tree diagram. And then this one B is white or blue. Okay, because the question said a white and a blue, a white or a blue. So if I change the question white or blue, then this is the answer. Okay, so now the question says a white or a blue. A white or a blue. Here means there's one white or one blue. So that means this one cannot be accepted. Okay, so maybe you can argue with me, right? So if you think that the answer is one, you show me, right? Okay, so this is why I said like that, because the word there, or a white or a blue, and the terms white or blue are different. Okay, so this is the example of question example 8. So stop here.